For today's lesson, we will be discussing about the power theorems, and we will start with the first one, which is Theorem 115. Theorem 115 is the intersecting segments of chords power theorem. It states that if two chords intersect in the interior of the circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chords. For example, you have this circle wherein we have segment AD and segment BE as the chords, and their point of intersection is point C. If you will notice here, each of the chords is now divided into two. So chord AD is divided into two parts. We have segment AC and segment CD, and on the other chord we have segment BC and segment CE. Now, applying Theorem 115, since the two chords intersect at an interior point, which is point C, then the product of the segments of one chord is equal to the product of the segments of the second chord. So, the equation here will be the length of AC multiplied to CD will be equal to the product of BC and CE. Now, if we multiply these two segments of one chord, it will be equal to the product also of the two segments of the other chord. So, to check if this is true, let's substitute the values. So, this is 15 times 2 equal to BC is 10 times CE, which is 3. Now, 15 times 2 is 30, and then times 3 is 30. So again, whenever the chords intersect at an interior point, then the product of the lengths of the segments of one chord will be equal to the product of the segments of the other chord. So another example is that, let's say we have here this circle wherein we have this chord EK and chord SI. And then their point of intersection is this point P. Now, applying Theorem 115, so again, the product of the segments EP and PK must be equal to the product of segment SP and segment PI. So let's write the formula here. So you have EP multiplied to PK, and that will be equal to SP multiplied to PI. Then let's substitute the values. So EP is X, then PK is 9, equal to SP, which is 3, and PI, which is 6. Now, our goal here is to solve for the value of X. So after substituting, we just have to simplify this. So this will be 9X equals 18. Then just divide both sides by 9. Then X will be equal to 2. Now, to check if this is correct, just again multiply. So you have X is 2. So this will be 18. This is equal to 18. And then 6 times 3 is again equal to 18. So the two are just equal with one another. So that means our answer is correct, which is equal to 2. Another one is, let's say we have this circle wherein segment PA or chord PA intersects with chord KR. And their point of intersection is an interior point, which is point D. So applying now the Theorem 115, we can say that PD times DA will just be equal with KD times DR. Now again, our goal is to solve for the value of X. So after making the equation, just simplify it until we reach the value of X. So PD is 3X multiplied to DA, which is 2X, equal to KD, which is 9, and DR, which is 4. Now this is 6X squared And 9 times 4 is 36. Then divide both sides by 6. So x squared is equal to 6. Then since what we're looking for is just the value of x, we just have to get the square root of both sides. So that means x is equal to square root of 6. Okay. So again, if you want to check, you can just substitute square root of 6 as x and then multiply it and check if the product of the two segments will be equal with the other one. So that's it for today. I hope you learned something about the first theorem for the power theorem, which is theorem 115. And see you next time.